In this video, I will explain how an electric stove works and the physical principles behind it. You will learn how electrical energy is converted into heat and why different types of stoves work in different ways. An electric stove consists of a cooking plate or a ceramic cooktop, an oven, and the associated controls. Inside, there are electric heating coils or wires that generate the heat. A thermostat measures the temperature and ensures it remains constant. The outer casing of the stove is usually made of metal and protects from direct contact with the hot parts. The electric stove is connected to the power grid via a special high-voltage line. This line supplies high voltage to ensure there is enough energy for heating. A typical household appliance uses 230 volts, while an electric stove is often powered by 400 volts. This allows the stove to heat up faster and more evenly. Inside the stove, electrical current flows through special heating wires or coils. These wires have a high electrical resistance, causing the electrical energy to be converted into heat. The heat generated is then transferred to the cooking plate or oven. The higher the resistance, the more heat is produced. In a traditional electric stove, the cooking plates are made of cast iron and contain built-in heating coils. Once electricity flows through the coils, they heat up and transfer the heat to the plate. The plate heats up and transfers the heat to the pot or pan. The temperature can be adjusted via a rotary knob, which controls the power supply. A ceramic cooktop works similarly to a traditional cooking plate, but uses a glass ceramic surface. Under this surface, heating coils are located, which heat up when switched on. The heat is conducted through the glass ceramic and reaches the pots and pans. Since the surface is smooth, it is easier to clean than a cast iron plate. An induction stove uses a magnetic alternating field to generate heat directly in the bottom of the pot. In this case, no current flows through a heating coil. Instead, an electromagnetic field is created. This field generates eddy currents in the pot's base, causing the pot to heat up. Therefore, only special pots made from magnetic material work on an induction stove. The temperature of an electric stove is regulated by a thermostat or special sensors. When the desired temperature is reached, the power supply is interrupted. If the temperature drops again, the heating element automatically switches on. This keeps the temperature constant and prevents overheating or excessive cooling. An electric stove has various safety mechanisms to prevent accidents. Many models feature a residual heat indicator that shows whether the cooking surface is still hot. Some devices have an automatic shut-off function that turns off the stove if it hasn't been used for a long time. Additionally, modern electric stoves are often equipped with a child safety lock to prevent accidental activation. An electric stove is easy to use and provides even heat distribution. Compared to a gas stove, it does not create open flames, reducing the risk of fire. Additionally, temperature and cooking levels can be precisely adjusted, allowing for accurate cooking of food. Modern technologies like induction also save energy and make cooking faster and more efficient.